Okay, so we're going back to calculus, and we're going to look at a new type of function called inverse trig functions. Okay, so at the end of the day, we're going to have some formulas for derivatives, and in another video, we're going to have formulas for integrals. And I have to show you where it comes from, but at the end of the day, there's just some formulas you have to know. So if I start with y equals sine x, we've done that lots of times, and it's a periodic function. But what I want to do is restrict the domain just to these values here. So I'm just going to get this part of the curve, okay, just that part of the curve. So it's still got part that you've seen before, but maybe you don't go backwards too often. So the range is -1 to 1. So the range is the y values. So what we've got here is, for every value of y, there's only one value of x. If I'd gone forwards, like for instance, if I thought about the function over here, there wouldn't be one value of y for every value of x. There'd be two values of x for one value of y. So I've got to restrict it to the back part, just between minus pi and pi on 2. Okay. So what's an inverse trig function? So when you're in year 9 or 10, when you're doing trigonometry, sine theta equals 0.7, and you had to use your shift button, what you were doing was calculating an inverse. So, theta is inverse sine of 0.7, which equals an angle. Okay, that's an inverse function. And you've got to remember also, and you probably don't, but inverse sine is not the same as flipping sine. Okay, sine minus 1x is what value what value of theta gives you a value which is not the same. Okay, so sine minus 1.7 is, theta equals what value to give you a 0.7, whereas 1 over sine is actually a substitution of an angle. So what does it look like? Excuse me. What does it look like when we draw it? Okay, so you could do a table of values. So for instance, sine theta equals 0, and so theta equals sine minus 1, 0, which is 0. Sine theta equals a half, so sine minus 1/2 equals pi on 6, etc., etc. And what you end up with is with this shape. Okay, so this shape here coming through, okay. The other function, if you just remember, the sine graph is that shape, and what you've got is the sine minus 1 is like a mirror image. Okay, so that pink graph is the graph of sine minus 1x, and you'll note that the domain and range are the direct opposite of what we had before. Okay, so again, I'm not going to be asking you to draw up the functions, but just note that there is a shape, and the domain and range of one flips to the domain and range of the other. Okay, so we're getting close to calculus. Okay, so similarly, we could draw cos. Okay, we could draw cos x, and where we've only got, for instance, I can go forward this time because for every value of y, there's only one value of x. So this time, for the domain and range, I'm going to go forwards to pi rather than, I don't need to go backwards. For instance, if I had gone backwards, then I'd have, for each value of y, there'd be two values of x. So I don't want to do that. I just want one value of y. And when you draw it up, you get that shape underneath. Okay, so cos minus 1 equals that shape. And again, I'm not going to ask you to draw it up in a test, but note that it has a shape. And the domain and range of the first function becomes the opposite for the inverse. Okay. So if we can draw a function, then we can find derivatives because we can find tangents at points, and we can also get integrals that lead to inverse trig. And this thing about the integrals, we'll do that in a later video. Okay, so I'm going to do the proof of where the derivative comes from. And again, I'm not going to ask you to do a proof in a test, but it's good that you know where it's coming from. Okay, so the function that we've got is y equals sine minus 1x. Okay, so to get rid of sine minus 1, I take sine of both sides. So x will equal sine of y. Okay, now x here is the same as x over 1. Now you know that from year 9, sine is opposite over hypotenuse. So if sine y, so that y there is the angle. So sine y equals the opposite, put a right angle there, opposite x over hypotenuse 1. So x over 1, that's the opposite, that's the hypotenuse. And this last side here along the bottom, we use Pythagoras, and we end up with this number here, so we've got m squared. Okay, so we've got m squared equals 1 squared minus x squared. We end up with 1 minus x squared inside a square root inside a square root sign. And then I'm going to use this later on, so I'm just going to calculate it now. So cos y equals the adjacent side over the hypotenuse, and the adjacent side is m, so it's 1 minus x squared square rooted over 1, which is just square root of 1 minus x squared. So that's what the value of cos, and I'll show you where we use it. And please jump too high. Okay, so let's go over here. So I've got this line here that I'm just going to change the side. So that is what we've got from the previous line. And I'm going to take the derivative with respect to y, okay, on both sides. So I'm going to take the derivative with respect to y. So when you get the derivative of sine, it turns into cos. And over here, this just turns into dx dy. So dx is there, so dx dy. Now normally, we don't have derivatives dx dy. We have derivatives that are dy dx, okay? So that's a derivative dy dx. So what we do is we just turn this upside down, and then cos y turns into 1 on cos y. And then we've just over here worked out that cos y was that number. So we end up with the derivative of what we started with is this little formula here. So it's just 1 minus x squared. So we're going to have a summary at the end, but what we've got here is if we have a function that's an inverse sine function, we'll do inverse cos and inverse tan later, but if we've got an inverse sine function, then the derivative is this neat formula 1 over square root of 1 minus x squared, and once we know what the x value is, we can find the derivative. And once we know the derivative, we can find the gradient at a point and a tangent. And so copy that down, but at the end of the day, I'm going to give you a nice little summary table which will give it all in on one page, basically. Okay, so unfortunately, we just can't have simple x, we have functions. So when we've got a function for sine minus 1x, we can use the chain rule, and we end up with this little thing. So instead of having, when it was y equals sine minus 1x, y dash was 1 over square root of 1 minus x squared. So basically what's happening is we're going to square the function, and then to compensate we're going to multiply by the derivative of the function. So here's a nice neat example. Okay, so that's a 2x, so that's my function. So sorry, cancel that. So fx equals 2x, so f dash x equals 2. That's pretty straightforward. And so basically what we're going to do is we'll have 1 over square root of 1 minus fx squared, so 2x squared equals 4x squared. So that's inside the square root sign, and then we multiply by the derivative, which is just 2, and there's nothing we can do with that. We just leave it like that. Okay? Okay, so let's have a look at... Okay, so what I've done, just to save time, with a similar proof, we can actually get the other ones as well, but let's cut to the chase. So if we've got cos minus 1x or cos minus 1 fx, the derivative is, for the first one, is just a minus sign comes in, and the minus sign comes in for the function as well. And then we just replace x with fx, and to compensate, multiply by f dash x. The one with tan is a little bit more interesting, and again, it can be proved, but we'll cut to the chase. We've got tan minus 1x and tan minus 1 fx, and so we end up with this little formula. There's no square roots. It's 1 over x squared plus 1, or 1 over fx squared plus 1 times f dash x. So I didn't actually repeat. I'll just see what I've done. No, so I didn't repeat. So if you can make sure, I'll just write it down over here. So when we've got sine minus 1x, the derivative is 1 over 1 minus x squared, and then the f dash x just becomes f dash x there and multiply by fx there and multiply by f dash x. So if you need to go back to the previous page to get the sine minus 1s, you've got the cos minus 1s and the tan minus 1s on that page there. Okay, so we'll look at some examples. Okay, so I've got an example for cos minus 1, and I'll go straight to some hard ones rather than give you baby ones. Okay, so the function is 1 over x, which is the same as x minus 1. So the derivative is multiply by the power, subtract 1 from the power, so you end up with minus 1 over x squared. So when you've got the derivative, okay, so I've got minus 1 over square root 1 minus fx squared times f dash x. And then obviously if you're panicking, you could leave it like that, but you're not going to get many marks. You need to tidy it up. So the square of the function is 1 over x squared. The minus sign still on top, and minus 1's over here. So we're going to keep going through. Okay, so jumped up a bit high. So inside here, what we need to do is we've got fractions. So I've cross multiplied x squared times x to turn them both over x squared. So I've got the x squared minus 1 over x squared, and then the square root of x squared is x. Okay, so that's on the denominator. And what's going to happen is, because you're dividing by a fraction, that x is actually going to go all the way back to the top. So I've got minus x over square root of x squared minus 1 times minus 1. The minuses cancel out to a plus. The x here cancels out with one of the x's there, so you end up with 1 over x square root x squared minus 1. Now obviously, if all I'm trying to do is find a derivative, then you don't need to tidy. If you're just trying to find the gradient at a certain point, you wouldn't need to tidy up. But if the question says, find the derivative, you've got to get as tidy as possible, which is that line there. Okay, copy that down when you're ready to come across. Okay, so again, we'll do a hard one for tan. So I've got a function square root of x, which is x to the half. So multiply by half, subtract 1 from the power. So you end up with 1 over 2 root x for the derivative. And so when you put it in, you've got your fx squared, like it used. So when you had tan minus 1x, it turns into 1 over x squared plus 1. So we've got to square it. So square the function, plus 1 multiplied by the f dash x on the outside. When you square a square root, you just get x plus 1, and then this one doesn't tidy up very much at all. Like, you just have to put a bracket around that and you're done. And that's the last page. So in that video, we've done derivatives of inverse trig. And then in the next video, we'll do the integrals that lead to inverse trig. So I hope you can go through that okay, and there'll be worksheets on Moodle.